for throwing away kind of thing. Which I don't know if it was legit. It seems like it was more of a like government standard kind of thing, and that's what they follow, than just like their standard.
I think they also mentioned that when the intensity goes below 70%, it actually started to dim the light, which is below the real intensity. And normally it happens so like slow that human eyes get accustomed to the decreasing part, so they don't realize that it goes below 70%. But if they see the light, two light together, one is went below 70% and one is 100%, they'll actually realize that the 70% is much dimmer than the one that has 100%. So it's they have some casting requirements and some intensity requirements that tell them to either, it will be either 50% or 70% depending on LED lights.
No idea, it's hard to pick up over time because they last 50,000 hours and you won't see a 30–40% drop over time. You just like eventually realize it's dim. You don't know how bad it is.
So you didn't reach the end of life?
Since we didn't have 50,000
You couldn't
hours
do
for
accelerated testing, though.
Yeah, exactly.
We actually simulated the aging process by moving the light from the source of sensor so that it decreased the intensity to the sensor when you move the light. So
We also had a dimmer
another
switch
way
too.
of simulating the light.
Yeah, initially we didn't think about that. Initially we thought like we had to do so many things. We actually bought a dimmer or using a potentiometer, to control the current to dim the light. So initially we didn't think it would be like that easy, smoothing out the light. So
Very good. Thank you.
Yes. Any other problems that arise when you start to go below that 70%? Is there anything besides the luminosity of the lights?
It does start to break down faster than normally. So what'll happen is like the light will slowly break down, and then once it hits 70 or 50%, it just starts going faster and faster and faster kind of.
I came in a little late, so you may have addressed this, but do you have to worry about the light sensor itself changing its response over a long period of time?
Yeah, we actually did some research and they sent some email to them, and they sent us back that the life cycle of light sensor are more than 120,000 hours.
Yeah, it was right. The failure rate was
816,000 hours was the average lifespan I got out of it. Before that, so
in normal operating conditions, like room temperature, it was like 800,000 before it failed. But other than that, I mean, it said that data remained reliable until they found.
I think there is only one problem with this diode light sensor or LED diodes is that the temperature, when the temperature goes above, I don't know why, but when the temperature is high, it actually deteriorates faster. So that's the only problem, the temperature.
And the light sensor ages when the power is off also, or not?
You should not.
No. I asked them specifically that question. They said like 90% sure that it doesn't age at all.
So you can turn it on only when you want to make the measurement.
Yeah.
Exactly.
That's exactly what we do.
It's just want to make sure initially their system does not unless the light on and does not measure the intensity. How many hours you wait?
Well, we can change, but I think we set 1 month, but we can change a week or whatever we want.
So after that period, then because the light after being used, it goes higher and higher, higher. At that level, they would set that is the level they would store, and against that they measure 70%.
Yeah.
That's the reference point.
Yeah, that's a reference point.
So do your studies indicate that LEDs are the light of the future?
It's must consume very low power. The board that we showed in here, it consumes only 7 watt. If we compare this board to a similar type of incandescent board, that will I think consume at least 500 watt. So you can see the difference. So it saves a lot of power.